The regression analysis is one of the methods of statistics to formulate a dependent variable by other explanatory variable, the regression equation, and to analyze each other variable's relation. The regression equation is expressed by the least squares method to make the difference, the residual, between the predicted values and the observed values, the least. The precision of this analysis is judged by the coefficient of determination. In other words, if the data, the observed values, has a tendency, it will be expressed by the linear equation as the following. There is some estrangement between the predicted values got by this equation and the observed values. This estrangement is called residual. The residual sometimes shows a positive value, other times it shows a negative one. So it is necessary for us to look into the degree of the estrangement by squaring the residual. It is called the least squares method to get A and B of this equation by minimizing the sum of these squared residuals. Predicted values, observed values, residue. Then what is the coefficient of determination? It is closely related with the variance, which shows the degree of the scatter which the distribution of the data has. Doing a regression analysis, the important terms include the following. 1. Mean. The numerical value divided the sum of all data by the number of the data is called mean. 2. Deviation. The difference between the data itself and the mean of the data is called deviation. 3. Variance. The numerical value divided the sum of the squares of deviation of each data by the number of the data, or n-1, is called variance. If the meaning and usage of these terms can be understood, the regression equation can be set up, and the coefficient of determination can be grasped. A and B in the regression equation, and the coefficient of determination can be expressed as the following. Look at this equation. As stated above the equation, this part of this term, is the sum of the squares of the residue. The lesser this is, the closer the coefficient of determination is to 1. And the more suitable the regression equation is for the analysis. In this way, it is called the least squares method to set the regression equation as the coefficient of determination is closer to 1. The multiple regression analysis is this application. In this simple regression analysis, the explanatory variable is only 1. But in the multiple regression analysis, the variables become more than 1. The multiple regression equation is expressed as follows. You will know the multiple regression analysis well, but some of you may not know the mechanism, so I explained this analysis basically here. When we apply a piece of real estate, we must analyze the value influences of the real estate. Above all, while performing an analysis of the subject neighborhood, we must grasp the market-specific value influences and quantify them numerically. The quantitative analysis is expressed as a gap rate of the market-specific value influences, which are useful to apply the appraisal approach, especially the sales comparison approach. The round value is generally considered the product of various value inferences. Value inferences are divided into general value inferences, market-specific value inferences, and property-specific value inferences. By the way, why do we have to quantify the market-specific value inferences numerically? Though there are various market-specific value inferences, they are generally classified into 4 groups in Japan. They are called the street condition, the traffic approaching condition, the environmental condition, and the public administrative condition. Street condition, traffic approaching condition, the environmental condition, public administrative condition. For example, the width and the kind of the street are the street condition. The character of the closest railway station and the distance from the station are the traffic approaching condition. The building to land ratio and the floor area ratio are the public administrative condition. We look into the real data of these inferences and substitute the gap rate for this data. We don't use the real data itself as a gap rate because the round value doesn't show the same response to the real data's change. For example, the ratio of 2 distances from the closest railway station, 50 meters and 500 meters, is expressed in the pair of 2 numbers, 1 to 10, using the common quantity, 50 meters of the 2. But it isn't appropriate to adapt this real data as a gap rate, which is used for the explanatory variable, because the adequate ratio fitted to the explanatory variable may be expressed even in the pair of 2 numbers, 1 to 20. So it is necessary for us to standardize the real data for the gap rate, which is fitted to the appraisal.